Hello everyone. Imagine like you are sending an email and the email carrier misread where is the ending of the first email and where is the starting of the second email. This mistake can lead to an attack called HTTP Request Smuggling. Most modern websites will not allow the browser to communicate directly to the server. Instead of that, they have a front-end server. This front-end server is the first place where the browser communicates. And this front-end server act as a middleman. These front-end servers take one HTTP request and add to the queue and then forward to the backend server. Here, the both backend server and the front-end server has to agree where the first request has ended and where the second request has been started. If the front-end server and the backend server fail to understand where is the first request end and where is second one starting, that lead to the HTTP request smuggling. This vulnerability arises when both front-end server and backend server interpret a request differently. Before we start the practical, we have to understand what we are going to do. So here, the practical is about CL.TE, that means content than transfer-encoding. This vulnerability occurs when the request or response is having two headers to verify the length of the content. That is content length and the second one is our transfer encoding. So here the content length is utilizing the number like 50, 30 like numbers to mention what is the length of the content is being sent. But the transfer encoding is using a different approach called chunked. Here the content length including the smuggled request, which means the real request and the smuggled request. So the content length is utilized by the front-end server and the transfer encoding is utilized by the backend server. This vulnerability occurs when both of these headers are in the request response. This is a request we are going to use for smuggling. So you can see over here, it having a post request and have content length, then the content length is 35. We can see here two requests. That is the first one is a post request, smuggled one is a get request. This is the request we are going to send to the server. You can see over here the entire content is given over here and this entire content having two requests. That is first one is a post request, that is a real request, and second one is a get request, that is the smuggled request. We can see here the content length is 35. The content length 35 including the smuggled request also. Then we can see here transfer encoding is chunked and it is having the value 0. 0 means it's a marker where the backend server terminate the communication. The value of content length is very long, that is having 35, but transfer encoding value is very short. I am going to explain what is happening over here. We can see a front-end server and a backend server. So here, when the request is being sent to the front-end server, they will check the content length as 35. The front-end server will process the request length as 35. Then it is forwarding to the backend server. Now, the backend server is seeing it as 0. Then the backend server is looking only the transfer encoding because if two headers are being used, the backend server will clearly ignore the content length header and they will look only on the transfer encoding. So here the backend server is only seeing 0 as the content length. Here 0 means 0/r/n. Here /r means move the cursor to the beginning of the line and /n means move the cursor to the new line. That's the meaning of this /r and /n. It is for the backend server. So what is going to happen over here? The backend server mark the communication is ending at the 0. But the problem is the front-end server is already accepting the 35 as the length. So because of this reason, the communication will still remain open because the backend server is only completing the first request, that is a post request. The second request is still in the 35 length. So the communication will remain open. Now what happened? Once the communication is remaining open, we can forward the second request to the server. So server will feel like this is a pending request and they will process it. I hope you understand the concept of this attack. Now let's try the practical. So let's start our practical now. This practical is about HTTP request smuggling by confirming a CL.TE vulnerability in differential response. We already studied about what is CL.TE vulnerability. Here, the front-end server is accepting the content length and the backend server is accepting the transfer-encoding. This is a target website. So as per the instructions given over here, our first objective is to find an error response. So for that purpose, we can provide any non-existing name in this URL. Here I provide my channel name as Hacademy and I got 404 error response. Make sure your Foxy proxy is listening. So see over here in the web suite, I can see my history. So this get method leading to HTTP 2 request. This is a targeted one. So we know that this HTTP request smuggling vulnerability exists only on HTTP 1.1. So for that purpose, we can manually edit or we can go for inspector window, then make the request as HTTP 1. Now we can again modify the method. So whenever a method is get method, there is no need of any parameters over there. But if it is a post method only, we can add any parameter values over there. For that purpose, right click over here and make the method as post method. Why? Because we are following this method, this will add the necessary headers automatically. See over here, the content type and the content length is been automatically been added. Now I am pasting the payload which is already been discussed. Here we can see the content length is 35 and transfer encoding is chunked. Here we can see the 35 is given. Like I explained before, this 35 content length means it include all the requests that include in the smuggling request, that is the get request. Upon seeing the 0, this is considered as a marker. So upon seeing this marker, the first request for the backend server will be immediately terminated. But since the forward server is having the value as 35, this communication will remain open because the backend server have processed only up to 0. Now, we can see here, I am sending the request to the server for the first time. The server is accepting the request and responding with a post request, which means now the connection is remaining open even though it will read up to the transfer encoding chunk 0 and send the request once again. Now we can see the smuggled request is leading to 404 that is not found. By the second time only our second request was forwarded to the server. As a result, we are getting 404 not found, which means we smuggled the second request to the server. See, we have completed the lab. I hope you clearly understand the concept of HTTP request smuggling. In the next video, we will discuss another attack. So see you soon.